All right, today we're looking at Unit 3, Day 7 slides, and it's actually going to be the last lesson of this unit. So we are almost to the end, we're almost at spring break, and we're looking at just solving some word problems with rational equations. Okay, so go ahead and have those slides open or have some paper out where you can jot down these problems and then fill in the slides after the video if you want. Looks like we have 4 word problems we're going to work out. All right, so before we get started, this is not on your slides. Your slides have just the 4 problems. But when we look at doing rate of work problems, which is what we are going to be learning today, they're called rate of work. You will read each problem and you will have 2 people usually that are doing some type of job, and they would complete that job at different rates. And then we'll also talk about if they work together, how long it would take them to complete that job. So when we set these problems up, we want to think of it like this. So you'll have the rate of the first person times the time it would take if they work together, plus the rate of the second person, again, times the time it would take if they work together, and it's always going to be equal to 1. So you're going to have a rate of the first person times the time it would take if they work together, and we're going to add that to the rate of the second person times the time it would take if they work together, and we're always going to equal it to 1 because they're equaling 1 job. So basically this portion ends up being how much of the job the first person completes, and then this portion would be how much of that 1 job the second person completed. And then what's important is to remember that a rate is going to look like this. It's going to be 1 job in however many hours or days, etc. So our rate is usually going to be 1 over something. All right, so first problem, Amanda. So Amanda is our person 1. Amanda can dig a 10-foot by 10-foot hole. Look, don't let all the numbers get in your way. Digging that 10 by 10 hole, that is the job that we're talking about this time. And she can dig that hole or complete that job in 7 hours. So what that means is Amanda's rate is 1 job in 7 hours. Okay. Then it says we have Mila, that's person number 2, and she can dig that same hole in 10 hours. So that means her rate is 1 over 10, 1 job in 10 hours. And then it says if they were to work together, how long would it take them, to complete this job? So remember, when we're setting this up, we'll take the rate of the first person, which we know, and we times it by however many hours, we're working in hours right now, it would take if they work together. Well, that's what we're looking for. How long would it take them together? That's X. That's what we don't know in this problem. So we are solving for their time together. Plus Mila's rate. And then again, we do not know the together time. That's what we're solving for, so that's X. And it equals 1. Okay, so what that ends up looking like, if you were going to solve this one out by hand, that would mean that this first fraction, 1/7 times x, when we multiply fractions, we multiply straight across. So it would end up looking like x/7 plus this one would look like x/10. So we would end up having like two separate fractions. So you have a choice here. Yesterday we looked at solving rational equations by hand. And if you would like to continue solving rational equations by hand, you can keep doing that. I'm going to show you how to type these in Desmos. Okay, so what we're going to do is we're going to go to Desmos and we're going to type in, again, I'm just going to show you a different way to solve. In Desmos, we're going to type this portion in as one equation, and then we're going to type the 1 as its own equation in Desmos. Okay, so we're going to type two separate equations. You might have done this in Math 2 at some point last year. So just like we had it, 1/7 times x plus 1/10 times x. That's going to be one of your equations. Now, if you just type 1 as your second equation, you can see nothing happens. It doesn't graph that. So you will have to do y equals 1. If you're not sure, you can just always do the y equals. Okay. So again, what we've done is we typed in from our problem, from our setup, we typed in the left-hand side as one equation and the right-hand side as its own equation. So that's how I have two separate lines right now. And all we're going to do is look for where they intersect. So they intersect right here when x is 4.118. And we were solving for x, so we're only using the x value. So a quick way to solve these, if you don't want to solve them by hand like we did yesterday, you could type in Desmos, find where they intersect, and get your answer. So 4.118 is going to be our answer. So if they work together, because that's what we were solving for, time together, it would take them 4.118 hours. Okay, so that's going to be our final answer. Again, if you liked solving them by hand yesterday, you can continue doing that. But you also can type these equations in Desmos, just showing you a second option. Okay, let's look at another one. The Delaware Demolition Company wants to build a brick wall to hide the area where they store wrecked cars from public view. One bricklayer, so that's going to be our first person, bricklayer number 1, he can build this wall in 5 days. Okay, so he can build one wall in 5 days. That's his rate. Another bricklayer, bricklayer number 2, he can do the same job so that makes the rate one job in 4 days. All right, so they decided they're going to hire both of them to work. How long will it take the 2 bricklayers to finish this wall? All right, they're hiring them together. They're working together. How long will it take? Remember, that is the time together in our little formula. So we're going to set it up the same way. We're going to take the rate of the first one times the time together plus the rate of the second one times the time together, which we're solving for, and it equals 1 job. So again, you have the option of solving by hand, or we can go to Desmos and type in the left-hand side as one equation. So that's 1/5 x and 1/4 times x. And then y equals 1 as the second. And you're just looking for where they intersected. So for this one, the X value is 2.222. 2.222, it's a lot of twos. This time we were in days, right? That was 5 days and 4 days. So together it would take them 2.222 days. Okay. All right, let's move to slide 2. Got a couple more problems. This time it's got Jan Zeiss, and she is tiling a floor. That's the job. And she can tile that floor in 14 hours. So her rate is 1 floor in 14 hours. Now this one's a little different. It tells us that together, Bill and Jan can tile that floor in 9 hours. So they gave me the together times. The together time is 9 hours. Okay, they didn't tell us the together time in the last problems. That's what we were solving for. So this time we're solving for how long it will take Bill to do the job alone. So what we don't know this time, we don't know Bill's rate. We know he can complete one job, but we don't know how many hours. So Bill's rate is 1 over x. It's not just x. Remember, the rate is 1 over however long it takes. And we're solving for how long it takes Bill. So we use the same formula to set it up, but be careful because this time we're solving for something different. So we know Jan's rate. We actually know the time together. It's 9. Plus, Bill's rate is 1 over x, and we still know that the time together is 9. These two parts are always going to be the same because the time together is the same. Okay, and then it's equal to 1 because again, it takes them 9 hours to do one job together. So you can still solve by hand if you want, or you can use Desmos. I'm going to just keep using Desmos on this video. So I'm going to go through and type in this left-hand side of the equation in Desmos. All right, so this one's a little different. We've got 1 over 14 times 9 plus 1 over x times 9, and it equals 1. All right, and the parentheses don't matter. I just put them there just in case any of you were typing it in. You could have it without the parentheses. All right, and then let's go and find where they cross. And if you can just zoom in any, I just like to click and eventually it will put the point there. So these cross at 25.2. X is 25.2. Now it seems like that's a really big number. But remember, this time we were solving for an alone time. And so if it took them 9 hours together, then we know it's going to take more than 9 hours for Bill to work alone. So we wanted something that was a little bit bigger. All right, last problem. Rodney and Thomas can build a cabinet together. Sorry, in 12 hours. All right, look, they can build a cabinet together in 12 hours. They told us the together time. Rodney can build the cabinet alone in 16 hours. So Rodney His rate is 1 cabinet in 16 hours. How long will it take Thomas to build the cabinet alone? So this is like the last problem we did. Thomas, we don't know his rate, but he can build 1 cabinet in X amount of hours. So set it up like we've been setting it up. We take the rate and we times it by the together time plus rate of Thomas times the together time, and they equal 1 job. And I'm going to type in the left-hand side to decimal, so 1 over 16 times 12. Oops, 1 over 16 times 12 plus 1 over x times 12. And find where that crosses the y equals 1 line. And when it looks like, you know, hey, they've crossed, I just click around the lines and it will put your dot up for you. And so they cross at 48 exactly. So X is 48 on this one. So Thomas is a very slow cabinet builder. It would take him 48 hours exactly. And again, you could have solved any of these by hand if you preferred that from yesterday, just giving you a separate option for solving these. The big idea on these word problems is getting the setup.